I guess I was muted. Alright. We're going to wait for a couple more people to roll in. Just pulling up the YouTubes and the Twitch right now. And we'll get started here soon. Alright? We're going to get started here soon. I'm going to go ahead and... of course, the camera's going to glitch out, so I'm going to go ahead and fix that, and then we'll put up a good old paint message here. Starting soon. Starting. There we go. And it is all being recorded, so, whoops. So, if you want to watch it after the fact, you can. It's being recorded, and we'll be cutting out some of these, like this waiting part at the beginning. Alright, let's go and fix the camera here. Webcam. Video. There we go. Alrighty. So we'll just wait for a couple more people here to join. We're just chilling, waiting right now. Before... What? Oh, yeah, it is working. Okay. We're just chilling, waiting here for a couple more people to join before we truck along here on our journey. I am in the Discord as usual, so if you are a Patreon or Discord premium member or a champion, you can go ahead and jump inside the events chat and ask any questions verbally at any time through the stream. If not, you can just go ahead and type in the YouTube and the Twitch chat. Those are both being monitored, right? Alrighty. Just waiting for a little bit longer here. I'm going to turn this down a little bit. Alright, while we wait, I'm gonna be right back. All right. We're back, just waiting. We'll probably wait till 2:10 and then start rolling along here. Why is the camera being all... Come on, camera. I believe in you. It's quite irritating. Why are you all blurry? Come on, focus. Focus. There we go. Much better. Do. Got a couple more minutes here before we chug along, waiting for any last stragglers to join. And again, all of this is being recorded, so you can go back and rewatch it later. Let me see here. Man, that kills me. Why is it not on there? Did I? Maybe I should check my hard drive. Alrighty. We got 3 more minutes before we chug on here with our regular broadcast. So we're just waiting, starting at 2:10. All right, I'll be right back while that is happening. Alrighty. Let us get into it, shall we? Where's the Discord? Pull that up. So, this class, we have done it before. The first time we ran through it was probably the best time. This time, we're going to run through it. It's going to be short. We're not going to go more than an hour here. Top of the hour, so for 50 minutes. And this is just going to be one of potentially many classes. It depends on how many people end up showing up and rewatching it afterwards, because this was a requested class not by supporters but by the masses joining for the AI aimbot and how to continue your journey here in machine learning land. All right, so we're just going to do a quick rundown. We're going to assume you have proficient knowledge in programming. All right, if you don't, then go watch 100 Days of Rootkit. I'm not teaching you how to program here. We're going to assume you know just a little bit about machine learning, that it's a thing, it exists, etc. And we're going to go over some history, and we're going to go over how you can start your career today, all right, in machine learning, and how you can start experimenting right off the bat, and some epic tools for getting into it. All right, as always, if you guys want, you can go ahead and just message in the YouTube or the Twitch chat anytime. I am checking those regularly. Additionally, like I said earlier, if you are a Patreon or the Discord premium server premium member, all right, you can go ahead, or server subscriber, whatever the term is for it, you can jump into the events chat and ask verbally any questions that you want at any time. All right, and we'll finish up with just a little bit of an intro here. If you don't know, we are a Rootkit nonprofit organization here in the US of A. Don't go to college, don't go to any other boot camp. You're already here, you're watching this, might as well jump over to the 100 Day of Rootkit streams. Watch all of them. We teach you everything you need to know to get our CompSci cert. Additionally, everything you need to know to get our CompSci cert is listed on our GitHub. So if we go view requirements, bam, it's all listed right here. So you can go learn that up. It's free 99. What are you doing? Get over there. Start learning. All right? Don't have to waste 4 years of your life and go into debt and not even get employed afterwards like college. And you don't have to be scammed like a boot camp. All right? Free 99. Start learning today. Get certified and get a job. It's really that easy. All right? Can't make it easier for you. So, let us jump into the world of machine learning, shall we? Let's go and pull this guy up. And this is not the right screen. All right. So, AI 101. All right? Everyone throws around this beautiful term AI. All right, it's just the biggest buzzword. It's been growing in popularity for the last couple of years. With the general discovery of GPT 3.5, with the general discovery of GPT 3.5 in the package of ChatGPT, people have gone nuts for it, even though it's been around for a while. Talking about a while, this presentation was made mostly about a year, 2 years ago. So some things have evolved and updated. All right. So the slides have not. So we're just going to move forward with it because they're still covering the foundational knowledge. But with the release of GPT-4 and what people are claiming as sparks of AGI, which is artificial general intelligence, people are looking very optimistic right now and are very bullish on the potential future of AI. We'll see. Because usually technology like this, history just repeats itself, all right? There's a big boom, and then there's a bust. And then there's a boom, and there's a bust, and a boom, and a bust. And eventually it will become not exciting anymore, but normal. Not so exciting anymore, normal. Kind of like the dot-com bubble. All right, dot-com early or late 1990s, everyone and their dog was making something that has to do with the internet, or saying it has to do with the internet, and people are going wild. Then it busted. Everyone lost all their money. They hated the internet, thought it was a scam. Then, again, everyone got hyped about it, and then it went downhill, uphill, and eventually just teetered off into, that's just something we use. Crypto's the same way. It's been hyped several times. There's been several booms. We're just leaving the potential last bust. All right, now it's starting to pop off again. So you'll see the same thing with crypto until it's just established as normal. And AI, we're probably towards the end of the cycles, I want to say, for just normal AI. For the general intelligence stuff, I don't even think we're really scratching the surface yet. But again, that's my personal opinion. You guys can form your own opinions here, because we're going into that cyberpunk dystopia. So before moving on, if you guys don't know, we just did the intro for Rootkit. We are a nonprofit here in the US of A. That link is wrong. It should be rootkit.org. We are a community-driven nonprofit. Pretty much everything we do is going to be open sourced, including our certifications. And we're all about the cutting edge, all right? So we are community driven. So if you want to volunteer, you get lots of perks if you volunteer and become a champion, all right? How do you volunteer? Well, we need help with video creation, YouTube videos, TikTok videos, writing scripts, editing videos, graphics, etc., etc. Certification development. If you want to help make certs, you can help us make certs, all right? And for the outreach efforts, different influencers, advertising, partnerships, etc. We're always looking to grow everything, and we are community driven, so we always do kickbacks. You help with YouTube videos, etc. You'll get paid a percentage of the ad revenue that it collects. For certification stuff, you will get paid a percentage of what the certs make in revenue. Don't expect you to become like a millionaire or something, but you will get some compensation. So, AI is a very big term. Too big, right? Too big. It's kind of like car, automobile, I guess. Automobile. No one just says automobile anymore. That's kind of weird, right? It's kind of weird, and it covers pretty much anything that's on the road. And that's a lot of different stuff. Car is more specific because it's only a certain type of vehicle. But automobile, kind of cringe, all right? Kind of cringe if you say that. Unless it's for like some type of official certification stuff. Same thing with AI. Most people in the field that are practicing and developing these systems, AI is like their favorite and worst term ever. All right, because it's so cringe, because it's used at it's just a massive broad term. All right, and no one can agree on this stuff right now, because if you look this up, everyone and their dog will have a different definition for every single thing, and you'll see as we go through. And if you do your own research, they will have everything worded differently, and I'm telling you how it is in general. So according to Britt Annika, AI is the ability of a digital computer or computer-controlled robot to perform tasks commonly associated with intelligent beings. All right, this is a very broad term. So broad, in fact, pretty much if you are programming, every program that you wrote can be classified as AI. This is also a great scam technique that lots of companies have used in the past, still use right now. The governments around the world use this scam technique. A bunch of government contracting companies use this scam technique. They'll brand things as AI, knowing that the definition here is so broad, and they're not doing AI as you think AI should be. They're just saying it because AI is a bad term. All right, it's too broad. Don't use it. Don't use it. All right, and you'll see here in a second. So AI is so broad, it covers things like pre-programmed routes or controls. All right, whether those are cars in game, Skyrim. Come on, would you? That's an AI. Like, does that even compare to ChatGPT? Come on. Dijkstras and A-stars, for any of you guys that are familiar with those algorithms. Auto clickers, go back to that term, tasks commonly associated with intelligent beings. Is clicking a mouse associated with intelligent beings? I would say so. Auto clickers, congratulations, are AI. Anomaly detection is AI, which basic math for that. Object detection, which is more realistic for AI. Well, nowadays, if you're using a neural network, which you are, if you've used YOLO, you're definitely using it in what you would classify as an AI today. Recommendation systems and translators. All right, it's so broad. So it just doesn't make sense for being used in a normal language. Additionally, a lot of people don't understand what's going on here. Right? They don't understand what's going on, and a lot of people don't know how to classify a lot of this stuff. There is and has been a lot of organization recently to kind of standardize the terminology and the graphs and etc. on what is used, but overall, it's still just hectic out there. All right, it's hectic out there. So these are a bunch of graphics you can figure out if you're trying to Google AI and get into this, and it's very confusing. It's very hard to get into machine learning because of how confusing it is. Because everyone and their dog is just saying something different and there's no cohesion. All right? So don't worry. You know what you do when you are confused and you don't know where to go? Go to the biggest player in town. All right? Go to the biggest player in town. Who is that? Microsoft, Google, Nvidia, and look at what they say and what they propose. And take that as word, because they are at the cutting edge of all of this. All right, don't listen to some stupid Medium article or whatever that you found online on your Google search. Anyone can write a Medium article. All right, so what you actually want is ML or DL. That stands for machine learning or deep learning. AI is too broad of a term. All right, as we went through, it covers pretty much anything you can do on a computer. Machine learning and deep learning, though, don't. Those are very specific, all right? And machine learning is half of data science. So if you are interested in data science, pretty much all data science can be classified as AI, and half of it could be classified as machine learning. The other half is more statistical, but that's not what our presentation is on. So machine learning is a technique by which a computer can learn from data, right? Without using a complex set of different rules. This approach is mainly based on training a model from data sets. Does that sound kind of familiar? It should, because that's what everyone means when they say AI. They don't actually mean AI, they mean machine learning. And what usually they actually mean on top of that is deep learning, which is a technique to perform machine learning inspired by our brain's own neural network network of neurons. All right. The machine learning and deep learning, the line between them can be a little bit confusing at first, but don't worry, we're going to draw it really distinctly. All right. The general exception is bigger. If it's bigger, it's deep learning, and you'll see what I mean by bigger here in a second. All right, let's move on here. So this is a great graphic from NVIDIA themselves that they have given several times during their conferences that they have twice a year. I forget what the conferences names are. But AI started happening back in the 1950s, all right? Which is, like, would you associate that with what we have right now on the just insane comprehension and ability that you're able to do? No. Again, it's a buzzword, right? It's a buzzword that encapsulates pretty much everything in the kitchen sink, all right? So AI early on was very, what do you call it? Manual, right? You're sitting there writing lots of code, producing lots of different algorithms to handle a multitude of different outcomes, all right? And, you know, it was definitely possible. And technically all machine learning is possible via normal programming. It just takes a very, very long time. So instead of you having to put in all the different rule sets or thinking about them and then putting them in, why not have the computer just figure it out itself? All right, start doing some learning. So that's where machine learning started happening. According to them, around the 1980s is when it started happening, but it didn't really, I think personally, didn't really take off till the late 90s, early 2000s, where we got a lot of unsupervised techniques, all right? Statistical techniques and unsupervised techniques, which basically were assistants to help you get some stuff done, all right, on your computer. They were the hardware for the time were pretty intensive, but today you can pretty much run them instantly on any type of hardware and not really have much of an issue. Starting around the 2010s is when GPUs really got powerful enough, all right? Because the big limiter on all of this going back in history wasn't the ideas. All of the bright math magicians, all right, even before the 1950s were already thinking about how these systems would exist and what it would take to build them. They already knew and wrote up and published papers on exactly how to go about this. All that we're doing kind of right now and that you can see is basically copying those papers and making it reality, because the hardware is finally good enough for us to start tackling these, right? So that's the biggest limiter. I mean, if you watch 100 Days of Rootkit, you'll hear me preach over and over again. Software development, you're never pretty much limited. Anything you think of, you can create. The software-wise, your biggest limiter would be time and hardware, typically. So as hardware keeps getting better and better, machine learning systems become easier and easier to produce at a larger and larger scale and more powerful. GPT is arguably only possible right now because of the improvements in NVIDIA's hardware, all right, with the GPUs and tensor cores, and it just massively speeds up things, all right. Deep learning, again, is building upon machine learning, but it's a little more complex. So machine learning, and this goes into deep learning because deep learning is inside of machine learning, can be generally split up into three major categories, all right? One is unsupervised learning. So this was pretty much the earliest stuff, all right? This is unsupervised, so you don't need to do anything. You say, computer, here's data, figure it out for me. And it will just automatically figure it out for you. This is extremely useful for these various tasks that you can see here. So do you use the YouTubes? Yeah, you're watching right now? Perfect. You're using their recommendation system. And this is how unsupervised machine learning is how they actually go about the recommendation system. It can actually be kind of visualized as a 2D plane with hills and peaks. And that's why, you know, when you find yourself down a rabbit hole, you might have fell down a peak and now you're getting recommended content around, a valley, and you're getting recommended content in that valley. You can go over to a new valley, but it takes a little bit of time to curve over. I wish I had a graphic for that, but I don't. What's up, Bruce? Other things that unsupervised machine learning can do: customer segmentation, visualization of data, and feature identification, which is super epic. Supervised learning is the more powerful stuff, right? GBT, that's going to be using supervised learning. That's going to be things like image classification, forecasting, predictions, optimizations, diagnosis, etc. Everything that you think of as modern and as real deep learning is typically going to be in the supervised learning category. So unsupervised, more primitive, right? Asterisks, quotes around that. Not really, but it is. Supervised learning is going to be what's really possible now because of a lot of the hardware improvements we have. And reinforcement learning is kind of a mesh between the two. You utilize supervised learning and unsupervised learning to have it just auto learn itself. So sometimes it's called hybrid learning because it is a little bit supervised, it's a little bit unsupervised. And this would be something that you just kind of want to set up with initial parameters and say, go. You don't really have initial data at the beginning. You kind of want it to figure it out for you. This is very intensive and can go really wrong really fast if you don't spend enough time setting up the correct things, because you can get stuck into valleys really easily. And if that doesn't make sense, hopefully it will later on. So this would be things like robot navigation, game AIs, and not normal video game AIs. I'm talking about the AI from the... God, who made it? Was it OpenAI that made it? The Dota AI that learned how to play Dota and beat the best Dota professionals, all right? Those types of AIs. And DeepMind from Google is using reinforcement learning to tackle protein folding, all right? So that's probably the last final step of just super powerful stuff, all right, is reinforcement learning, but it is a little tricky. So unsupervised learning, I like this graphic a lot. It's pretty much like a genius child, right? And it's only meant for gaining insight on data. It's not really useful for, telling you exact things. What do I mean by that? So genius child, you don't need to tell it anything besides, hey, here's a bunch of data I have. You throw it at it and say, figure it out, buddy, all right? I don't got time, just figure it out. And it will just auto-magically figure it out. This is because, for this example here, if you have a bunch of pictures of dogs and cats, if you chuck it at your computer, it will automatically sort it into similar groups. Because dogs and cats, they both look slightly different than each other, so it will pick up on that and separate them. How it does this is typically through clustering techniques. So clustering technique is a way a computer can basically find clusters of things and kind of wrap them together and say, this must be the same thing. All right, or I'm certain percent confidence that it's the same thing. Additionally, it can be used for useful things like anomaly detection, where everyone here is, in the blue, and this is what normal looks like. And when someone tries to do something bad, this is not normal. This is not connected to the rest of the group. This is not how people usually act. So that must be wrong. This is something that's growing in popularity, unsupervised machine learning. More, I would say, it's used more than traditional, or not traditional, in more modern machine learning, like supervised machine learning, because it's way more lightweight and it can potentially give you more insights immediately without very much hardware overhauls. Again, you could run a lot of these on CPU only, which a lot of servers, that's all they got. It's a lot of extra cost to get GPUs. A good new case for this would be NVIDIA has firewall systems, which will basically auto-analyze traffic, figure out what normal is using unsupervised machine learning, and then anything that falls outside of that, it will automatically flag. And it's been proven to actually identify new 0 days before anyone even knows those 0 days exist. So it's pretty neat. Below, we got this great little graphic here kind of showing unsupervised machine learning and how it kind of grouped these little clusters together automatically. So these are going to be words, and it's just grouping these words together. Yeah, it's just kind of a visual example for you. Now, the other big counterpart here is supervised machine learning. Unlike unsupervised, which kind of seems like a genius child because you just give it things and it just does it, and it produces beautiful results for you. Supervised machine learning is basically a dumb child, right? It's absolutely stupid. It doesn't know anything. It's just the dumbest thing in the world. What you have to do is teach it. But luckily for you, the computer will just automate this for you. Now, anything that can be done with machine learning can be done through normal programming means. You can write yourself every algorithm that is necessary to do pretty much anything a machine learning computer would need to do. Except that takes a lot of time. All right, why spend potentially years programming up image detection when you can write a machine learning application that will learn from images you feed it in potentially a week? All right, a week, a lot better than a year, if you ask me. So by default, it doesn't know anything. So you must label all of the data. That's the important thing here, is labeled data. This is a very, very painful task. There is no quick way around labeling data, unless you filter in digital twinning. But we're not going to talk about that right now. Basically, if you take a photo and you want to learn on that photo, you have to manually draw what you want it to identify and label it. It is a very time-intensive process because you can't just use 100 images, 1,000 images. It's best if you potentially use hundreds of thousands of images. This is such a painful process that there are lots of systems out there that you can utilize to pay grunt workers, all right, to label this for you. So if you're in the US, you're going to be going to probably something like Amazon SageMaker data labeling, where you're paying either minimum wage workers in Seattle, or if they're offloading it to some Asian countries, then you're getting basically slave labor. All right, they already put their employees in what they're pissing in bottles and stuff. All right, but prices are really cheap. So a pro, I guess. All right. What you have to do is, once you label all of this data, for example, we want the machine to learn what a cat is. We have to label a bunch of images with cats and then give it to the machine and say, hey, this is what a cat looks like. Do you understand? And if it understands, you say, oh, good machine. If it doesn't, you say, learn what it is, God! So there are rewards for it getting it right and wrong. And depending on whether it gets it right or wrong, basically the brain that you build for it will shift up and down until it can identify things correctly. There are two things that you can do, major things you can utilize for supervised machine learning, and that would be classification and regression. Classification is something that pretty much most of you guys are familiar with, especially if you're using the aimbot. YOLO is classification, aka you feed it something and you ask it what it is, all right? And it classifies it for you, all right? Regression is going to be something like predicting the future, or how things are going to move, or how is it expected to output later on. I believe, again, I'm a little bit rusty, but I believe regression is what GPT is going to be using, because GPT predicts what next words are going to be utilizing, right? Don't quote me on that though, right? Again, like I said, the slides are a little old and I'm a little rusty on some of these items. Whoops. So if you're watching 100 Days of Rootkit, this should look very, very familiar to you. Everyone asks, how is this magic possible? What are they utilizing? Well, very primitive computer science techniques, right? All machine learning applications are built off the concept of graphs, right? Where you have nodes and edges. Right, so right here we have nodes and edges. This might seem a little overwhelming to you, but it's actually a third grader could have drawn this up, all right, and it would have made sense, right? All this is nodes and edges, and the numbers can be potentially anything you want. For example, travel time. Let's say this is a subway system map, right, where each one of these are stops. And these are the routes to each one of these stops, and the time in there on the lanes or the edges are how long it takes to travel. So going from 0 to 1 takes 4 minutes. From 1 to 8 takes 2 minutes, etc., etc. And then I ask you, how do you get from 0 to 4 the fastest? And you need to calculate the fastest route to 0 to 4. Congratulations, that's machine learning, all right? So when you go down your route here, these are basically going to be the neurons, mimicking your neurons in your brain, and this is what ends up calculating, depending on the path that you take, what you're trying to predict or classify, etc., like that. It's very primitive techniques used under the board. It's just the way they automate that makes it powerful. So this is what your computer brain literally looks like. All right, it's just nodes and edges, right? Nodes and edges, lots of nodes and edges. A single setup like this, where you have two nodes and two inputs and one output, is going to be called a perceptron. I don't know why that sounds really weird to me right now. That is basically the simplest unit you have in regards to neural networks and what they call every little node and edge. You know, they don't really use the node and edge term. They use the perceptron term. So you'll also see these labeled as slightly separate things. Oh, thanks for the subscription, Eugene. I have my volume off here. Actually, let me check the chat real quick. All right. So you'll see these also called as perceptron machines, multi-layer perceptrons. You'll just see the term occasionally thrown in there, usually when someone wants to feel smart about themselves, whenever I've seen it. But usually you don't really see that term. You'll just see as nodes, neural networks, layers. All right, and there's a bunch of basic versions of it. There's lots of spin-offs, all right, and this is again all in regards to supervised machine learning. And this is the layout for it. So you have radial, you have multi-layer, which is more than one layer, all right? So a layer is this vertical up and down, right? So the blues are going to be input. So if you have a photo that you want it to tell you what it is, blue is going to be your photo being entered, and yellows are going to be the output, right? What is that thing? It doesn't have to be photos. It could be anything, audio, text, etc. Recurrent neural networks and LSTMs are both kind of the same thing. They're for memorizing, right? They're for memorizing something. So, they're for backwards feeding memorization. So basically you compute something, and once you compute it, that answer, it feeds it back into itself. All right. So it's a way to, LSTM is long short-term memory. It's for it memorizing things. These are basically the components in regards to things like GPT. I think they used something slightly different. I can't remember right now. But that's how it remembers, what it recently typed in. Instead of you just getting random words printed out, you kind of need to understand some of the past. A stock market is a good example. To predict the next move in the stock market, you got to know potentially what the last 30 days looked like. So LSTMs allow you to do that. There's Hopfield networks and Boltzmann machines, and I believe these are ways for, I'm forgetting right now, I believe there are ways for unsupervised machine learning also. Deep learning is effectively anything that is multiple layers, right? So everything from radial onto LSTM here in this graph would be considered as deep learning because they have multiple layers besides the input and output, all right? They have multiple layers. That's pretty much the simplest definition for deep learning. So it's quite trippy if you look into this and into the layers, because the thing is, early on, the people didn't really know why or how exactly it was learning. It was just learning. And there's been lots of studies and time being taken right now to investigate all these models on a deeper level, because the idea is if we can figure out exactly what's going on with all these neurons in these simulated brains, maybe we can understand the brain itself a little bit better. So here are some of the neurons that have been probed in the I believe is ResNet neural network, and these images here, I believe, are based off these images here, or maybe it was the top ones. No, I think the top ones are just the default ones, but as you can see, it's identifying patterns and various other things that don't really make sense to you at first, but they make sense to the machine. All right. Let's see here. So you can do a lot of things with machine learning. And again, it pretty much works auto magically as long as you set it up right initially. The hardest thing is the data. All right. The hardest thing is data. So for photos and videos, you can do a variety of things. All right. So there's classification, which is just one general classification for that photo. All right. I give you a photo, might be a family photo, and in that family photo, the machine identifies a ball. And that's what it calls it. It calls that photo a ball. Why? Because there was a little ball in the background. And that's what it saw first, and it just went with that. All right? Not great for predicting multiple things. It's just great for one thing. All right? So classification, one thing for the entire image. Classification plus localization is the same. You get one prediction for that entire image, but it will also start drawing a bounding box. All right, that's what that localization is, telling you exactly where that item is. Object detection is what something like YOLO uses. All right, so that will be identifying multiple objects and an understanding of multiple objects within the same scene, plus drawing bounding boxes, which can be very, very useful. And then after that is instance segmentation, which is detailed outline around exactly what that item is. This is extremely useful in pretty much everything, right? Object detection is great for speed, right? But in instance segmentation is the best all around for pretty much everything. You want to make a better Photoshop? Great. Use that. It can find people and then you can remove it. Remove those people. In video editing, it's being used pretty heavily for cropping, moving, etc., etc. If you want to modify the aimbot, that would be a great improvement, because now you can be more exact on exactly where you want to be aiming, because you're getting the exact outlines of everything. So super resolution, right? This is something that everyone should be familiar with. DLSS. Should know what that is. It's all the hype right now. That's NVIDIA's deep learning on DLSS. Deep learning super sampling. All right. So super resolution is also sometimes called super sampling. Everyone calls it one term or the other. Effectively, it's just a fancy name for enhance. Right? You see in the movies where they're like enhance. The comedic thing was, it's not really a thing, right? Never really has existed before. It's kind of made up sci-fi crap. Now it exists, right? Now it exists for super resolution. Now it's not actually pulling out new stuff. It's just kind of predicting what is there. So you can see an example of it right here. So that's what DLS does, is it renders your game at a higher higher quality, lower resolution, and then uses machine learning to upscale it. All right. Action detection. So if there's someone in a photo punching or in a video punching and doing something, you can detect what action they're taking. So if you want to have a monitoring system that looks for crimes or violent crimes, you could use a action detection system to find when someone's being violent. Object replacement, which we kind of talked about earlier. There's Nerfies, which this video is for, and I guess isn't showing up right now. Nerfies are basically, you can take a photo, and that photo automatically will become a 3D image. Simulations, OCR, and ITT and TTI. So OCR is going to be for optical character resolution. So you want to read in characters, you can use OCR. Arguably, that's way of doing classification, object detection, etc., etc. And then ITT and TTI, which is going to be image to text and text to image. This is a very popular thing right now, specifically when you're using Stable Diffusion and what's the other big one? I'm forgetting the name right now, and I like it better too. Whatever. We're gonna move on. Whoops. And then for your natural language processing, did we skip one? No. NLP. All right. So this is going to be everything for text only. So NLP, you have things like text to speech. All right. Speech to text, sentiment analysis. So effectively, like, what is someone feeling? Feature extraction, which you can kind of see right here. You know, you give it something and you say, give me the person, the location, and the org that was in here. Translation. Makes enough sense. Topic modeling. So this can be unsupervised or supervised, and that's basically I give you a bunch of documents. What is the gist? Organize them for me, etc., etc. Summarization, which is summarizing the documents. Codex. So things like GitHub Copilots runs off of Codex, and that's effectively programming for you. Math, which is GPT's very capable of doing, and humans, OpenAI, Cohere, both of their systems are very much human-like. All right, and they are competitors to each other, and their systems are very scary, as everyone has now learned. Now, there's also audio slash signals. So audios, we say audio, and audio is like the most fun thing. You can see audio, you can hear audio, so it's fun to hear and mess with. But this goes beyond normal audio. Any type of signal, so anything in a waveform, can have machine learning imposed upon it with any of these techniques. All right. So whether you're listening for gravitational waves or I don't know, whatever else, different infrared, ultraviolet light, I don't care. Whatever you're doing, all of this can be applied to it. All right. So there's speech to text and text to speech. All right. For signals, this can be done to produce signals that you can basically say like, I want make a signal to open my garage, and it just makes it. All right. In reverse. All right. So this is very, very popular right now, especially on YouTube, all those great Biden stuff. So here's a couple of videos. I think, was this one for the end? I can't remember right now what this one was for. And then there's this one right here, which is all done with, this is all AI, well, 3D generated, with some slight AI generated. And then Jensen here is AI generated. This is all AI generated.
Hospitals smarter for the future.
Basically, everything you know is going to be done by an AI eventually, right? If not right now. Super hearing. So if you have audio, you can basically enhance, all right, that audio so you can hear better, hear more, and more clearly exactly the things that you want to hear. Noise reduction. So better, smarter noise reduction. Because right now, a lot of noise reduction is done with manual algorithms, but like I said, you can do anything manually that a machine learning application can do. But machine learning applications can potentially make it way faster and potentially better in a quicker time than you would be able to. Synthesis, so making fake signals, recognition, recognizing certain signals, and classification, so classifying those signals. Alrighty, let us move on here. What are these for? Can't load the audio right now. So when you are utilizing machine learning, for the love of God, just don't use your CPU. All right, it's not going to be a great experience for you if you're using your CPU. If you're doing lightweight things like unsupervised learning, you can get away with your CPU. Right? You can get away with your CPU for most of it. But overall, use GPUs. Right? Use GPUs or TPUs or FPGAs. TPUs are going to be your tensor processing units, which pretty much only meant for machine learning, because all the calculations are going to be done as tensors. And field programmable gate arrays, if you don't know what those are, don't worry about it. All right, only you'll be dealing with those only if you know what they are and you're really into this stuff. All right, CPUs are very inefficient and expensive. All right, when you want to do machine learning, doing parallel processing is very, very important. All right, and floating point operations are very, very important. CPUs are not great at either of those. By not great, I mean they pretty much can't do them, and if they can do them, aka the floating point stuff, they're not fast at it all. GPUs just happen to be very convenient, all right, because when you're doing images, you deal with floating point values, and you're doing a lot of stuff in parallel. So it's just a easy translation to machine learning. All right. Now, invested NVIDIA. All right. No, don't. This is not a financial advice, but pretty much NVIDIA is the king. They have a monopoly period. If you want to do machine learning, you do it with NVIDIA hardware. There's not really anything else you can utilize. The only thing you could say is TPUs, so custom TPUs that maybe Google has or other companies are developing, and then the FPGAs. But overall, you're going to be using NVIDIA hardware. All right. AMD has been. Who's AMD? All right. AMD has pretty much screwed themselves over. They've just not been with the machine learning game. All right. So they have pretty much very little support overall. They are trying to get on top of it right now. So I'm happy to see that, and hopefully they get their shit together. But we'll see. We'll see. Yeah, you're pretty much have to use NVIDIA. So as you can see here, when you're using things like NVIDIA GPUs, this is specifically for the P100s and V100s, which you only use if you're using a cloud service. You can see the performance is quite a bit different, right, for your compared to your CPU. And this is using a Xeon, right, E5 2690, compared to the P100 and the V100 on ResNet 50. All right, let's go on, and here's some more graphs for you. So something you got to be aware of when you're doing machine learning is it is easy to do. You can pretty much stand something up, throw some data at it, and have it do a thing. But just because it does a thing doesn't mean it does it well. All right, again, most of your time is spent on everything else but the training. All right, on prepping, going through, double checking, making sure your data is great enough, because you want to avoid biases. All right, biases like sample biases, prejudice biases, and measurement biases are very, very important to avoid, because you can get things like these results when you're using super resolution. You know, you can turn Obama here into Chad, all right, or Chad, I should call him, all right, because you didn't feed it enough people of just different types in general. You fed it too many white people, right? Plain and simple. So you got to make sure your data sets are diverse. And by diverse, I mean like start with perfectly balanced, right? Because some people might want to say, you know, if they're making something for the US, maybe they should just go based off the percentage of, for example, if you're doing image recognition of people, they might want to do initially the percentage of, you know, each type of race in the US. Don't do equal parts, everyone, because it's just not going to work very well if you feed, you know, 1% for, I don't know, there's definitely some race that's only 1% or less. So make sure you feed it a lot of everyone so it can really understand everyone. Additionally, you can get weird things like this happen. All right, I think this is more so a meme than anything else, but mislabeling will cause errors and issues, and you don't want that. Again, like I've said multiple times, and this is pulled straight from AWS, your ML and ML code is just one small part. Most of your time is going to be spent on the data, right? So configuring everything, getting the data, extracting features that you want to learn from the data, doing data verification, all right, managing your resources, analysis tools while it's learning, after it's learned, and then running everything on servers, all right. Maybe you're not using a server, maybe it's just running on your computer, and then you finally, you know, chuck it and it runs. All right. It's pretty much it automatically happens when you run it. Everything beforehand is the most important part. So how can you get into this? How can you start utilizing it? You can start utilizing quite easily. There's a bunch of links here for Hugging Face, PyTorch, NVIDIA's NGC, AI.Facebook, and TensorFlow.org. These sites will allow you, these all go to different types of hubs where you can download pre-trained models and data sets that are state-of-the-art and start using them today. You don't need to know pretty much most of the behind scenes to start using machine learning. You can quite simply just plug and play and have it work. All right. You don't have to train it on your own data set because machine learning applications will deeply understand what is going on. All right. People constantly join the server and like, oh, is it going to work in this game? Yes. Is it a humanoid character? It's going to work. All right. Because YOLO is trained to understand humanoids at a deep level. All right. And you can get even better models that are even more accurate than YOLO, because YOLO is not the most accurate model out there. It's just really, really quick. It understands it at a deep level. If you jump to different games and I ask you if that's a human, they're wearing a different suit or something, are you gonna like forget what a human looks like? No, you don't. All right. Same thing with these models. They are trained to know things at a deeper level. So Hugging Face is really great. You can go to the model section here and see lots of great models that are pretty much just plug and play. You want the clip model by OpenAI? Great. This is what it does. You give it photos and it tells you things that are in the photos. How do you run it? There's the code, copy and paste, bam. You have clip model now running in your AI model, in your application. It was just that easy. All right. PyTorch Hub is kind of setting itself up in the same way, but it's not that great. There are a couple good items in here though. There's the NVIDIA NGC, which is an absolutely great resource if you want to go down the NVIDIA rabbit hole. Highly recommend looking into it. There's the AI Facebook tools that are available, which I recommend just taking a look through it and seeing what's here, but they usually don't update it too much. And then there's the TensorFlow Hub, which you can look through. There have been a couple good finds here, but I believe last time I was going through it, they've really oriented towards web-based models. So models that you can run in a browser, or an individual can run in the browser and just have kind of work quickly. Let us see here. So what are tools that you can use to get into machine learning? Here we go. NVIDIA Rapids, Hugging Face's Transformers, which is kind of a wrapper on top of PyTorch. PyTorch is probably one of the most popular ones out there because they made it really, really easy to use. PyTorch is maintained by Facebook. TensorFlow is maintained by Google. PyTorch and TensorFlow are the two biggest libraries for making machine learning app models, right? Making machine learning models. Onyx is kind of a middleman, right? It's just kind of a file format that's universally acknowledged, all right? But you will be developing most likely in PyTorch or TensorFlow if you're going to be making supervised models. You may also be using Transformers, which is using PyTorch on the hood. Rapids is really useful if you want to do just general data science and unsupervised machine learning. Utilizing the GPU just right off the bat. This is made by the NVIDIA themselves. NVIDIA has a bunch of their own products also that you can use, like Nemo and Tau and Morpheus. There's a bunch more that they're always releasing, and they're actually super powerful. And I highly recommend going on the NGC site and going down the NVIDIA rabbit hole, because they are setting up to pretty much continue their monopoly. And there's scikit-learn, which is basically the de facto library that lots of people that want to get into machine learning start off on. There's most of it's unsupervised machine learning techniques, but there are some supervised machine learning items in there. But it's pretty much plug and play. It only uses your CPU, so you're not going to get the best performance out of it, but it works, and it works like a charm. So I highly recommend checking it out. And their site is set up for you to learn. So it's pretty easy to use. As you can see here, this is from 2021, so quite old for machine learning talk, right? Quite old indeed. This is made by MLReef, so I wonder if we can actually get the new MLReef one. MLReef machine learning graphic. Is this the... No. Okay, well, I'm not going to go down this rabbit hole too much more. This is the same one. Yeah, because I saw the version number at the top. But this is kind of a quick overlay of how the machine learning world used to look like back then. As you can see, lots of different products for pretty much just about everything you need to do. So utilize these products, look them up, spend some time exploring, all right? So you don't have to start from scratch, because everything's kind of set up right now where you don't have to start from scratch. You want some data sets? Great. There are data sets available at Hugging Face. Click on data sets, bam, here are a bunch of data sets. Go get some data sets. There are lots of other sites that you can use to get some data sets. And these are not small data sets. These are really, some of them are very, very large data sets. And by large, I mean like hundreds of gigs to terabytes large. This one is, I must have missed it. Let me scroll up. This one is going to be 1 million to 1 billion characters, records. I'm not quite sure. Files. Let's see here. This is just kilobytes. Here's the data. As you can see, there are lots of files in here, and this one alone is 3 gigabytes, right? It looks like it's, oh, this is the train stuff. Regardless, this is not I guess the greatest example, but go look through this, right? Most likely you don't need to do it yourself. There's also Kaggle that you can look into. It is a very popular site. And they have lots of data sets also, so go ahead and check out Kaggle also. Again, you don't typically have to start from scratch yourself. You can use something like Kaggle or Hugging Face, get the data sets you want. You can go into the models here, find the model that you want, and you can continue training the model or fine tune the model. You don't need to train the model from scratch. All right. I don't recommend training models from scratch unless you need to or you know what you're doing. Right? I recommend just fine tuning or continuing its training. And let's see here. So here's a great link right here to a great blog to run you through and talk about all these different types of neuron setups. So if you're interested in getting machine learning, pretty much these pretty pictures are the best, all right? Because if you want to read the research papers of how, something like GPT was made, effectively they're just going to be describing these pictures, right? They're setting up everything to look like this. So they'll be talking about the different layers that they have, what are in each one of those layers, what's the general setup, are they using RNNs here, LSTMs, GRUs, are they using autoencoders at all, is it a GAN, the generative adversarial network, etc., etc. And all these ones listed here are pretty great to know, all right? And each one has their own purpose, and I highly recommend you just learning about it, because again, I've said it multiple times in this class, and machine learning is quite easy to get into and start doing. The hardest on-ramp, I would say, is just the terms. There's a lot of new vocabulary you have to learn. But if you're a programmer, pretty much you're good. There's nothing more you have to really learn besides just the library itself. But the terms are a lot. Take time to learn the terms, to learn all these items, to get familiar with them for several reasons. One, you can't really build a model unless you know these terms and know what you need to put where. And second, what are you trying to do? And what neural network works best for that? The only way to know that is you need to start learning what all of these are, and that will pretty much answer your question, because there's been lots of smart genius people out there that have spent lots and lots of times time figuring this stuff out for you. So just use what they've already figured out. All right. Don't try to write stuff from scratch unless you really want to go down a rabbit hole. All right. And I think on the next one, we're going to get into our Hello World program here. So it's very traditional for you to do the MNIST application when you get into machine learning. So I have a link here, and I'll put this in the Discord. Basically, when you go to this link, you can run it in Google Colab, which I highly recommend you utilizing. But this is basically you setting up your first machine learning application, training it from scratch, and then running it. And it's based off the MNIST data set, which is basically character recognition, right? Something very, very simple and easy to use, but easy to get into. All right. So we'll continue. I'll put this link again in the Discord, and we'll continue the next class with starting off with running this from scratch, talking about every one of these steps a little bit in details, and then showing how you can hack AI. All right, because it's not something that's talked about a lot right now, and it should be. A lot of these systems are actually kind of easy to hack. You can hack machine learning pretty easily. All right, it's not what you think of normal hacking. It's more of I feed you an image, and I want it to think the image is something else. All right. Any questions, comments, or concerns you guys have before we end this lesson? I'm going to go ahead and drop this link. Into here. And into here. Perfect. All right. I don't see any other questions. So we're going to call that good. And I'll see you guys on the next one.